So, very good morning, students. So, welcome to IIT NEET Foundation Program or Focus C by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 9th students for today's session. As you all can see on the screen, or you are well aware, my subject is physics. We are in class 9, our ongoing chapter, work, power and energy. And today we are entering into the second session. That is, we started this chapter in the last class and we'll continue where we stop in the last class. But before that, let us recall what we learned in the last class. So as you can see, we learned about the first word, that is work. So it's a commonly used word in our day-to-day application. But when you come to physics point of view, there is some difference. So whenever, suppose in general, our terminology, when you are sitting in the school from morning 8:30 to 4:30, you feel that you have done a lot of work. Commonly, you might have written notebooks, or you might have copied from the board, or you might have seen the online classes. All these things are not work as per the physics. As per the physics, work is said to be done when a body displaces in the direction of force. This, when you are applying a force on a body, it should move its position. When the body changes the position in the direction of force, then only work is said to be done as per physics. But when you are sitting in the classroom, you are not moving, sitting at same place, and you are doing work, that is not a work as per physics. Right? And this work can be either positive work is there. We have seen examples also. Can be negative, or can be zero work also. Right? For example, when a force makes some angle with the direction of displacement, means force is acting in one direction, body is moving in the some other direction. I told already, like a road roller or lawn roller for cutting the grass we'll use. So we'll apply the force in downward direction, but the roller will move in the horizontal direction, making some angle with the direction of force. If that angle is 90 degrees, the angle is perpendicular, then the work done is zero. Means when the direction of displacements makes an angle of 90 degrees with the application of force, the direction of application of force, the work done is zero as per the formula W is equal to F into S cos theta. For example, I told railway coolie or bus stop coolie, when they are carrying the luggage on their head, see, when they are placing the luggage on head, the weight acts in the downward direction, the force, completely because of the gravitational force. But the person is moving in the horizontal direction, which is 90 degrees to the direction of force. So that means that the work done is zero in that case, as per the physics, not as per our day-to-day application. Right? So the work done can be either positive with the force and direct displacement of same direction. It can be negative when the force and displacement are in opposite direction, and even it can be zero also whenever the force makes an angle of 90 degrees with the direction of displacement. So the three possible types of forces we'll discuss in the last class along with some important examples. Okay, now when you move forward for today's session, so we learn about the another important term in the chapter, that is power. So you all know the power. This is a commonly used word again. You all know the power, but when you come technically, when you come physics point of view, it will define in a different way. So see, power is nothing but work done only. Power is nothing but work done. But how fast you are doing work done means work done in terms of time. Suppose you have study hour, target hour, or E&D class, whatever it may be, same name. 5 questions will be given on board. Teacher is given, mathematics teacher is given 5 questions on board. And there will be have time 40 minutes of study hour or 45 minutes. So all the students know all 5 questions. You all know all 5 questions. But some of them completed in all 5 questions in 40 minutes. And few of them come to only 4 questions. Few of them come to only 3 questions. Few of them only 2. Why? Even though you know all 5 questions, whether you have completed the target within 45 hours or not is important. That is how fast you are doing your work. That is the rate of work done. The work done against the time. How fast you can do is called as a power. That is, power is equal to work by time. Work by time. So, work is measured in joule by second, or it is also measured in erg by second, or it is commonly named after a great scientist, Watt. Clear or not? See, all the T terms which are there in chapter, work, power, energy, all three are interlinked. All three are connected to work only. When work is done, we can case as energy. How much capacity you have is your energy. But how fast you are doing is your work, your power. So you can have more energy, but less power. Means you can do the work. Whatever work is given to you, you can do. But you cannot do fast. When you can do, that is called your energy. When you cannot do fast, that is called your power. Simple. Clear? So power is nothing but the rate of work done or the work done in unit time. How much work you have done a given time is called as the power. That is, the rate of doing work is called power. Power is also a scalar quantity because it doesn't have any direction. It can act in any direction. So the power spent by a source is measured as amount of work done by a source of in 1 second. Thus, power spent by a source depend on following 2 factors. That is amount of work done and the time taken by the source to do the work. Based on these 2, we can calculate. Suppose a 10 labor we kept. So how much work they have done for cutting the trees. So how many trees by end of the day, we can measure their power by how much amount they are getting. Why? Because those who do the work fast, they can get more amount. Similarly, as means how fast you are doing the work is the power. Simple. Rate of work done or work done in a given time gives your power. Clear? Power doesn't mean that muscles. Power doesn't mean that gym. Going gym and get the power. No, that is not a power. It may be your physical power or mental power. Everything depends on how fast you are doing. Right? Suppose they given some example here. So if coolie labor A takes 1 minute to lift a load to roof of the bus, while another coolie B takes 2 minutes to lift the same load to roof of the bus. The work done by both coolies is same, but the power spent by coolie A is twice that of power spent by coolie B, because coolie A does the work at a double the rate, that is half in the time. Same luggage is there, but one fellow keep it in the roof of the bus in 1 minute, second one is 2 minutes. So definitely you can say that first person is having more power because he done the work in the half of the time as second one. Clear? So if the constant force acting body, okay, so the mathematical power is given W is equal to F into S and power is equal to work by time. You can write another way also. In other way you can write it. So power is equal to some other equation. Power is equal to work by time. But what is work? Work is the force into displacement by time. But what is displacement by time? Distance by time is nothing but velocity. So P is equal to force into velocity also we can write as per our requirement. Right? Wherever you see force can be written as either W by T or you can write force into velocity also. Right? So okay, so that is the power. And this power is measured in either joule per second or erg per second or watt. What is the common unit for the power? So when you see horsepower, another word is going to see here. Horsepower. Generally for engines of two-wheeler or four-wheeler, their power is measured in horsepower. What is horsepower? Horsepower is nothing but 746 watt. Brake horsepower they'll give the for vehicles, BHP. How much brake horsepower is there? Based on that, we'll take the vehicles. The power of engine is measured in brake horsepower, where horsepower is nothing but 746 watt. Very powerful engines will have the big power. Clear? So this is about again power. There is another way to derive the power formula. Average power. The power of water drawing from pump. What power we should have to draw the water from the well. How to define the power. Everything is given. Right? So before going for the energy part, we have something about the video about the power. Then we move to the energy, right?
Work and Energy. Part 5. Power. In the previous video, we learned about the law of conservation of energy. In this video, we will learn about power. Do you think all human beings do their work at the same rate? Or all the machines consume and transfer energy at the same rate? The rate of doing work varies with all the individuals, and different machines also work at different rates. Now, let us have a look at a simple activity to understand how the rate of doing work varies for everyone. Suppose two athletes A and B decided to take part in a 100-meter race. Both are of the same age and have the same weight. A completed the race in 25 seconds and B completed the race in 20 seconds.
See, the difference is time.
What do you think is the work done by both A and B? Same work is done by both A and B, but B takes less time than A to complete the same work.
So that
Who
is the
do you
power.
think did more work per second? A stronger person can do a certain amount of work in a relatively less time.
You got na? Just
Similarly,
less
a
time,
more
more work.
powerful
You can call it
car
as a power.
can cover more distance in a short period of time than a less powerful car. These cars are classified according to their rate of doing work,
That is the power of the car. I don't know horsepower.
and power measures this rate at which work is being done. Thus, power is defined as the rate of doing work or the rate of transfer of energy. Now, let us look at the mathematical formula of power. let the work done by an object be W in time t. Then power is equal to work upon time. P is equal to W upon T. The SI unit of power is watt, which is denoted as W. The SI unit is named watt
James
to
Watt.
honor the
Pressure
Scottish inventor
steam
James
engine
Watt.
invented.
1 watt is the power of an agent, which does work at the rate of 1 joule per second. 1 watt is equal to 1 joule upon 1 second. 1 watt is equal to 1 joule per second. Bigger unit of power is kilowatt, denoted as kW. 1 kilowatt is equal to 1000 watt, which is equal to 1000 joule per second. Power may vary with time. That is, the rate of doing work may be different at different time intervals. Thus, here the concept of average power becomes helpful. Average power is the total energy consumed divided by the total time taken. Remember, we studied about energy and its units. Now, let us learn about the commercial unit of energy. As joule is not enough to measure the larger quantities of energy, the commercial unit of energy is kilowatt hour.
So you can
1
make it
kilowatt hour is the energy consumed in 1 hour at the rate of 1000 joule per second. 1 kilowatt hour is equal to 1 kilowatt multiplied by 1 hour, which is equal to 1000
Kilowatt
watts
1000, 1000
multiplied by 3600
hour into
seconds,
seconds. 60
which
into
is
60.
equal to 36 lakhs joule, which is equal to 3.6 multiplied by 10 raised to 6 joule. This unit is also used in our households.
Electric meter.
Let us take a simple example to understand the usage of the unit kilowatt hour. Take a look at the
See.
electricity meter in your
After
house.
going home, you can see the electric meter in your house from where the bill will generate. It looks like this. Where it is written as kWh. Means the electric meter measures the energy consumed by you at home in kWh. Whatever the units you can say, na? One unit is nothing but 1 kilowatt hour. 1 unit means 3.6 into 10 power 6 joules you consumed, either through TV or through refrigerator or AC or geyser. Any electrical device, it consumes energy in terms of kWh, kilowatt hour, which is nothing but 1 unit. How many units you consumed, by end of the month, you will get the bill. Correct or not? Every electric bill will get it. That is based on this only. After going home, once you check whether kWh is written or not. And these are the numbers which are showing there are the how much energy you consumed, how many units you consumed. Okay, very important.
Observe it closely. Take the readings of the meter at 6 am and 6 pm for a few days. How much energy is consumed by your family during the daytime and during the night time? In this video, we learned about power.
It is clear about the complete what is power, right? So we completed in last class about work and different types of works. Now today we completed power and what are the practical units of power and what are the largest units of power. Now we come to the last part of the last word of the chapter, that is energy. Work, power, energy. All the three are connected to each other. They are interrelated. All are defined in terms of work only. So what is energy? That also will use. If you take must nice food, you will get the energy. We can do much work. We can have much power. Means the power or energy or work depends only on the common point. So when you come to energy, energy is nothing but the capacity to do the work. The energy of the body is defined as the capacity or ability or tendency to do the work. How much capacity you have to do a work, given work. There is no time will come here. If time comes, that will become power, right? Since energy of the body is the total quantity of work done, therefore it is a scalar quantity. So energy is, as it is a work done only, it is also measured either in joule or erg. Some other also there, like just now I showed. That is, it is also measured in kilowatt hour, electron volt, or calorie. All these are the different types of practical units of energy. Commonly measured in joule or erg, where the relation is there. See, 1 joule is equal to, that is, joule is in MK system, erg is in CGS system. So 1 joule is equal to 10 power 7 erg. 1 electron volt also given 1.6 in 10 power minus 29 joule, minus 19 joule. That is charge of electron. 1 kilowatt hour, just now we have seen 1000 watt hours. 1000 into 3600. So you can point, right? 3.6 10 power 6 joule. 1 calorie also is measured in calorie, where 1 calorie is equal to 4.18 joules, come across in heat chapter. Right? So all these are the practical units of the energy. How much capacity you have to do the work is called energy, which is measured in either joule or erg or electron volt or kilowatt hour or calories. Right? Then various forms of energies, what we can see in day-to-day life. So mechanical energy. Mechanical energy means either energy possessed by a moving body or a body at rest. Energy possessed by moving body is called kinetic energy, and energy possessed by a body at rest is called potential energy. Right? So both together called as mechanical energy, or it also muscular energy also comes in the category. Chemical energy. So in chemicals, laboratory you have so many chemicals which have their own energy to do work. Electrical energy. Electricity also a lot of work. Without electricity, even we cannot imagine our life. So electromagnetic energy, that is one kind we come across in higher classes. Nuclear energy, very powerful. Most powerful form of energy. That is hydrogen bomb, atom bombs, which are devised by this method only. Sound energy. Why you call sound energy? Because with sound also we can do lot of work. Light energy, thermal energy. Thermal is nothing but heat. Heat energy or thermal energy. All these are the form of energies only, which we'll discuss in the physics only. We cannot discuss these topics in either in Telugu, Hindi, or English, or social studies, or mathematics. So study of energies comes under our physics. And all these energies are useful for us in some or other forms, other point of time. Everything you can see here. All these will use. There are wonderful form of energies they are. Right. Now when you come for the one-on-one description of this, you can see here clearly what are the mechanical energy they given. Mechanical energy, as they classified into mechanical energy of two types. One is kinetic energy, other one is potential energy. So the energy possessed by a body, virtue of its motion, every moving body possesses the kinetic energy. Clear? Examples. Flowing water possesses kinetic energy, which is used to turn a wheel to produce electrical energy. Like, for example, dams are there, Nagarjuna Sagar Dam, some other dams, where the flowing water, with flowing water, we can produce the electricity. So such flowing water, energy possessed by that flowing water is kinetic energy. Right. Next, moving vehicle. Every moving vehicle possesses the kinetic energy. Next, the moving hammer possesses the kinetic energy. Right. Which is used to drive the nails into wall, wood. We are hitting the nail into the wood. So that moving hammer also passes that only. Then a bullet fired from a gun. So it passes the kinetic energy. These are a few examples where you can see the kinetic energy. Every moving body possesses kinetic energy. That's all. Whether it's a vehicle, or it is a hammer, or whatever it may be. So when you go for explanation, that is mathematical derivation. So kinetic energy is given by half mv square formula. 1 by 2 mv square. Mass into velocity square. How you got it? From this equation. From W is equal to Fs only you get. Okay. So 1 by 2 mv square is the mathematical formula for the kinetic energy. Right? So this is the one part of energy, kinetic, which is the form of mechanical energy. So further we'll go in the coming class. So we'll discuss about the what is work energy theorem, the relation between the work and energy, and other forms of energy. So many types of energies are there. We'll discuss one by one: electrical, potential, gravitational. Okay. So in next class, we'll continue the same. May take one more class to complete about the total types of energies and some mathematical relationship between the work and energy, which is comes under work or energy topic. Okay. So in next class when we meet, we'll complete that part to enter the next chapter, that is circular motion. Right? So that's all for today. Today we learned in depth about we recall what we learned about work, and what is negative work, what is a positive work, and what are the zero work and mathematical formula for work. Then we enter into the power. We discuss what is power, how it is related to the time, and what are the practical units of powers, starting from watt to joule per second, erg per second, kilowatt hour, and electron volt. So many are there. Then we enter into the energy. So we have seen there various forms of energies, and we started explaining about the one by one, where we started only with the kinetic energy, which is energy possessed by a body, virtue of its motion. Means every moving body produces kinetic energy. Clear? So that's all for today. Thank you, students. Have a wonderful day. Thank you.